Well, hello everyone, and welcome to another fantastic session here at ANZ Summit 2022. My name is Rovan, I'm a Principal Technical Account Manager, and with me today I have Stephen Salim, who's a well-architected solution architect, and we both work at AWS. So let's start why we're here running this session today. As a TAM, I work with many customers on cost optimization, and I usually get lots of questions and also feedback. So I compile some of the common questions and challenges customers talk to me and my peers about. Things like, I don't know where to start on cost optimization, or how do I know I'm on the right track? How can I allocate expenses and charge back to different business units and make them aware and accountable of their usage without really slowing them down? How can I avoid bill surprises? And the most common question is, how can I get my cost under control and continue to track it? Driven by this feedback, we built a session to cover two main things. One, to walk you through AWS design principles for cost optimization, so you know what framework to follow, where are you at, and what to do next. The second thing is, after we talk about each design principle, we will walk you through the tools that you can use to put those principles into practice, and then we'll wrap up with a short demo. The guideline we are going to use for cost optimization is AWS Well-Architected Framework. It built around 6 pillars: operational excellence, security, reliability, performance efficiency, cost optimization, and the recent additional pillar, sustainability. So why would we want to apply well-architected framework? For one, it provides a consistent approach for customers and partners to evaluate their architecture and implement scalable design. And in doing so, it will guide you through AWS best practices and how can you measure against them. So when you incorporate these pillars, it will help you produce stable and efficient system, allowing you to reduce firefighting and also wastage. Our focus in this session is on cost optimization pillar, so let's check it out. The cost optimization consists of 5 design principles, which could be your goals, and then 4 main focus areas to help you achieve those goals. Those principles will help you adopt the appropriate mental model when optimizing cloud cost, ensuring you take advantage of the capabilities of AWS and free yourself from the constraint of traditional approaches. Something to point out is investing the right amount of effort in cost optimization strategy upfront is always going to allow you to realize the economic benefit of cloud by ensuring consistent adherence to best practices and avoid over-provisioning from the start. Another thing I want to point out, I have customers tell me, well, we followed the design principles and we've done cost optimization. When should we stop? My answer to that is, cost optimization is a continual process of refinement and improvement over the lifetime of the workload. There are times when you want to slow down as you achieve your cost optimization goals. And to get there, you would have followed the design principles, established standardized process and automations that reduce your cost. Then congratulations, you're really in a good place. Then divert your energy to innovation, but get back again and reiterate your cost optimization journey. So let's do a deep dive into each of the cost optimization focus area. All right, the 4 focus areas of cost optimization in cloud are implement cloud financial management, cost-effective resources, manage demand and supply, expenditure, and usage awareness. So let's deep dive into each of these. Starting with expenditure and usage awareness, we need to understand what drives our cost to be able to manage it and identify cost reduction opportunities. The first thing is we need to decommission unused resources. If we design our workload to perform automated decommissioning, that will automatically reduce the overall cost of the workload during its lifetime. The best way to do this is to implement the standardized process to identify and remove these unused resources. To do so, you can use AWS autoscaling to perform the decommissioning process when you want to scale down. You can also implement custom code using API or SDK to decommission unused resources automatically. The second point is governance. As any system, you have to develop cost goals and targets to your teams. The goals are to provide direction on expected outcomes. An example would be, workload need to be more efficient every 6 months, meaning cost should be decreased by maybe 5% every 6 months. And then targets, which provide specific measurable outcomes. An example would be 20% increase in the platform usage while we maintain less than 5% increase in cost. Another thing to point out here is to use or assign organizational meaning to cost and usage. And we can do that by implementing tagging. So what tagging allows to do is add information like cost center, environment, maybe dev or prod, project owners to cost and usage reports, which makes it easy for us to make sense of cost when we run reports or do any platform analysis. Moving to monitor the cost and usage, it is important to be able to attribute cost of resources to business units, which drives the efficient usage behavior and help reduce waste. So you have to be aware of usage at all levels in your organization. And there are a couple of things to help you get there. One of the things we want to do is to configure detailed data source, and we can do that by enabling hourly granularity in Cost Explorer and create cost and usage report or core file. These data sources provide the most accurate view of cost and usage. So AWS Cost Explorer, alongside Cost and Usage Report or core file, are some of the main tools to help you monitor your usage and cost. Now let's talk about one of AWS tools that will help you not just monitor spend, but also identify anomalies. So going back to customer feedback to minimize cost surprises and enhance control without slowing their teams down, AWS thought about this feedback and released cost anomaly detection. So what does cost anomaly detection offer? It uses machine learning to monitor your spend trend, including organic growth and also seasonal trend, and then detects unusual or unexpected spend and provide you with root cause analysis so you can act on it. It also allows you to create your own contextualized cost monitor and receive alerts when any anomaly spend detected. The anomaly detection itself focuses on monitoring spend by individual AWS service, cost allocation tags, cost category, and linked or account members. And these are aligned with the most frequent requests and asks from our customers and their day-to-day processes for detecting anomalies. Another thing is anomaly detection will alert the people or the teams you specify when costs become abnormal, which reduce the time you need to spend monitoring cost and notifying your teams. These alerts obviously are flexible. You can increase or decrease threshold to decrease the number of false positive alerts. In regards to root cause analysis though, cost anomaly detection identifies the drivers of the anomaly, including account ID, the service that is responsible for the anomaly, besides the region and usage time. So cost anomaly detection will help you start addressing the spike in spend immediately, and instead of dealing with the outcome when you receive the bill at the following months. So, moving from detecting anomalies and enhanced control to another feedback from our customers about their visibility into multi-tenant workload and how can they charge back to business unit. The chargeback model depends on the ability to identify and isolate individual tenant consumption of AWS resources. If each of your tenants has their own AWS account, then it's easy as you can use Cost Explorer to attribute the account cost to the tenant. However, if you have a multi-tenant account, it becomes a bit tricky, and being able to correlate your tenant to the resources they are consuming is foundational to chargeback model. So, to solve this problem, AWS released Application Cost Profiler. So what does it offer? First, it provides a granular cost and consumption insight of key shared AWS resources in a detailed summary report. It also removes the need to build custom analysis solution, which will reduce your operational overhead. Add to that, it enables a correlation of tenant usage data with AWS cost, considering special discounts and saving plans. And you can get consumption insight across tenant base with the ability to view data in multiple dimensions, example time, region, or service. I added here an example of the insight that Application Cost Profiler provide on the detailed consumption of AWS resources across region divided by tenant. Upon you sign up, you can generate your Application Cost Profiler report on a free tier for the first 30 gig of output data. All right. Here is the second focus area, manage demand and supply resources. When you move to cloud, you pay only for what you use, which help you eliminate wastage and over-provisioning. You can use a number of different approaches for managing demand and supply resources. The main thing here is you need to analyze the workload to know its requirements. The analysis should include the predictability and repeatability of the demand, and also the rate of the change in demand. Let's start with how we manage the demand. In order to manage demand, you're going to use either throttling or buffer-based. You want to use throttling in sources that has a retry capability. So throttling tells the source if it cannot serve the request at the current time, it should try again later. And you can use Amazon API Gateway to implement throttling. Buffer-based is similar to throttling. A buffer-based defer request processing, allowing application to run different rates, and it uses a queue to accept the messages. You can choose from multiple services to implement buffering, things like Amazon SQS and Amazon Kinesis. The other thing is dynamic supply, and there are two elements to that. Demand-based supply, and here we want to leverage elasticity of the cloud to supply resources to meet changes in the demand. The services that can be used here are auto-scaling, which help you adjust the capacity to maintain steady, predictable performance at the lowest possible cost. The other one is elastic load balancing, which help you scale by distributing the demand across multiple resources. The other element is time-based supply. And a time-based approach aligns capacity to demand that is predictable or defined by time. This approach is typically not dependent on the utilization level of the resources, but more on the timeline to ensure the resources are available at a specific time frame. For example, start of business hours on Monday or Friday. And here you can use schedule auto-scaling to implement time-based approach. So your workload can be scheduled to scale at in specific time. You can also leverage AWS APIs and SDKs, CloudFormation, to automatically provision and decommission entire environment as you need them. So let's start to talk more about some of these services and features that AWS provide to match capacity with demand. For DynamoDB table, with idle or maybe unpredictable workloads, we then recommend you to use DynamoDB on-demand capacity to save cost. For storage on S3, with Amazon S3 intelligent tiering, you can optimize storage costs as storage objects are automatically moved between frequent to infrequent access tiers based on the data access pattern. For EC2, you can use AWS Instant Scheduler to automatically terminate idle EC2 and RDS instances that are not in use and start them again when the capacity is needed. You can also update underutilized instance identified by Cost Explorer in EC2 console. Then the instance scheduler can automate stopping those idle instances you identified. You can also use EC2 autoscaling to improve the application availability and control costs by automatically adding or removing EC2 instance according to the condition you define based on the fluctuation in the application demand. Being able to match the application capacity with demand ensure you are not over or under provisioning resources. And with that, I'll hand over to Stephen, who will walk us through the other two remaining focus area of cost optimization. Steve?
Thank you, Robin. So the next thing I'd like to talk to you about is on choosing cost-effective resources for your workload, because making sure that you're using an appropriate service and configuration is actually key in being able to maximize the cost benefits for your workload. You can have two workloads running with the same capabilities, perhaps utilized the same way, or running the same application altogether. But if you run it on top of two different set of services and configuration, the cost that will incur will be different. Now, there are several things that you want to consider in making sure that you're running with the most cost-effective resource. The first one is taking cost consideration early in the process. Back to the very beginning when you're selecting the type of service that you would use for your workload. Now, in doing this, it is important to remember that cost-optimized workload does not necessarily mean the one with the lowest cost. You want to take into account your historical utilization data, the inherent licensing model, and choose the appropriate operating model, such as using serverless or managed services like Amazon RDS. The goal here is to find the service that offers the right balance in ensuring that you're meeting organizational requirements with the most cost-effective manner. The next thing is to choose the best pricing model for your workload. AWS offers multiple pricing model, which essentially allows you to choose the way that you pay for your resources. You can choose pricing models such as on-demand, spot, reserve instance, or savings plan, and align that with your organizational needs. And you want to perform modeling to capture the default on-demand pricing and compare them against other applicable model for the resources that you choose. And perform this on a regular basis so that you can make a small adjustment on purchases and align the coverage with the changes of your workload along the way. Now, oftentimes, when designing a workload, the things that gets missed out is taking into consideration the data transfer costs. AWS actually offers multiple networking resources with different prices for scenarios of data transfer. Because of that, it is important for you to plan and architect for the data transfer to minimize the cost. And performing a data transfer modeling will also enable you to understand where the data transfer occurs, the cost that it entails, along with the associated benefit, which will be very beneficial for you to make an informed decisions when you're modifying or accepting architectural decisions for your workload. The next thing is to ensure that you're running your workload using the resource type, the size, and the number that meets your technical requirement, but at the lowest cost possible. To do this, you essentially need to perform a right sizing activities, which involves modeling your costs to understand the balance between your resource and find the correct size for each of the workload given a specific level of performance. And if you unpack this sentence, what you essentially need to do in the background is to first of all look at the utilization of your resources and over time measure it, and based on that data, find the matching resource size that could support you but at a lower cost. And all of this is done so that you can make an informed decision to change the size of your resources without compromising on your application performance. This is where AWS Compute Optimizer can help you with your right-sizing effort for the case of compute resources such as Amazon EC2, Audit Scaling Group, AWS Lambda, or EBS volumes. The service allows you to save time from manually performing activities that we've just described and allow you to access right-sizing recommendations with a single switch in your account. AWS Compute Optimizer will scan your resources continuously and use machine learning to analyze historical utilization metrics and configuration. It will then use the data to provide you with up to 3 types of recommendations around options for your resources. These recommendations will contain information on savings opportunity along with the ranking of what is the potential performance impact that it may have in your workload. This information will be very useful for your engineering team for them to evaluate a price-performance trade-off for the workload before actually making changes to the resource size. The next thing in the focus area that I'd like to talk about is around practicing a cloud financial management. The first thing in building your cloud financial management is to quantify the business value that will be delivered through your cost optimization effort. This is very important because ultimately your cost optimization is an investment that you need to make. And quantifying the business value will help you explain the return of investment to your stakeholders and therefore gain more buy-ins. This will also provide you with a framework to measure your outcome for any ongoing optimization activities. Now, while doing this, it is important to remember that the benefit of cost optimization actually goes beyond just cost reduction or avoidance. You want to capture additional data to measure the improvements on efficiency and business value that you're gaining to quantify the actual value of your effort that you spent. For example, an investment on creating a resource lifecycle management using automation. This will create a potential cost reduction in your infrastructure costs, but also beyond that, it will also increase your organizational agility and potentially uncover new opportunities for revenue generation. The next thing, which is equally as important, is to have a function within your organization that focuses around cost management and optimization. This function is essentially your champion for cost optimization, and depending on the size of your org, this could range from just being an individual to a dedicated cross-function team of multiple stakeholders from finance, technology, or other parts of the business. The function will spend a required percentage of their time doing cost management and optimization activities. The goal here is to establish a partnership between key finance and technology stakeholders and to bridge the gap and create transparency around cost and usage, and to also establish a process and procedures around costs such as budgeting and forecasting. The speed and agility of cloud creates a highly variable cost and usage pattern for your workload. To give you a picture, your cost can decrease when you increase your efficiency, such as using a better sized EC2 instance through a process of right sizing. But when you increase on the demand and you need to scale your workload to serve it, subsequently, your usage and cost will also increase along with that. This is why it's very important to incorporate cloud variability into your existing organizational process, which can be done by adjusting your existing budget and forecasting process to become more dynamic. And you can do this by either looking at historical trends of your usage or business drivers such as new product launch, region expansion, and etc. Now, there are multiple solutions that can provide you with extensive help and toolings around this, but at a simplest form, a native AWS service that you can use for this are AWS Cost Explorer and AWS Budgets. AWS Cost Explorer supports capability for trend-based forecasting. It allows you to estimate your cost for up to 12 months time period, and it will look at your historical spend, and depending on the volatility and fluctuations, it will give you a range of forecasted values at an 80% prediction level. And you can use these forecasted values to decide and set budgets using AWS Budgets. With AWS Budgets, you can set up a customized budgets. You can create your budget based on your costs, usage, your ROI, or savings plan. You can apply filter using tags or parameters of your cost usage to narrow it down to resources that you want to apply budgets to. And you can set up an alert which sends out an email or a message to your Slack channel once your threshold has exceeded. So that was a little bit about budgets and forecasting tools on AWS. The last thing I'd like to talk about in cloud financial management practice is to establish a cost-aware culture and process, which is basically the heart of your cloud financial practice, because it allows you to scale your effort and establish capability with minimal effort. This can be done through small changes in your organizational culture by doing things like giving recognition to voluntary cost optimization to encourage a proactive behavior in your team, or a top-down requirement that drives accountability and to run your workload at a predefined budgets. Now, along with this, it is also important to embed cost awareness into the existing process to support the culture that you're trying to encourage in your organization. Another thing that is also important to consider when doing this is to also create a conducive environment for your team to actually perform the desired culture, and to leverage tools and automation to reduce the friction and streamline the process. In the next couple of minutes, I'm going to show you a quick demo to illustrate this scenario. Now, as I mentioned before, one of the things that you can do to establish a cost-aware culture is to encourage accountability in your team and require your workload to run at a certain budget. But if you wait until the end of the month to send the cost report for your team's visibility, chances are it's already too late. To do this, you want to actually provide visibility early and give them the opportunity to remediate the situation. And one of the ways that you can do this is to leverage the alerting mechanism in AWS Budget. Now, over here, we have a console for AWS Budgets. What I'm going to do next is to show you how to set up an alerting mechanism to notify your team if the current spend is about to reach the budget threshold. So the first thing that I'm going to do is create a cost-based budget, and we'll provide it a name. We'll set up the budget period to be on quarterly basis, and we'll enter a budget amount for our workload. We can then set up a scope of the budget to either look at AWS services or to narrow it down to certain resources based on the dimension. For this demo, we're just going to use all AWS services. Now at this point, we can set up an alerting mechanism of our budget. We can set the threshold to specify at what percentage of the budget that we would like to be notified. And then we can select a notification settings that we can choose to either send via email or send a notification via our instance messaging platform using AWS Chatbot. Now, another aspect in creating this visibility is that we want to leverage a mechanism that supports the culture that we're trying to encourage. This is why leveraging an instant messaging platform like Slack channel is a great way to encourage transparency. And injecting our alert into the platform provides instant visibility to our team, and it gives them the platform to take immediate action and become proactive. So in this case, we're going to go ahead and set up our budget notification to our Slack channel. Now, as you can see here, our alert in the budget has been triggered. And if we look at our Slack channel, we can see that our notification has been delivered, and it is now visible directly to the rest of our team in the channel. Now, provided this visibility, our team members are now able to take proactive actions in remediating the situation. They can do things like proactively look for any low priority instances that they're not using and stop them temporarily to bring the cost down until the budget recycles. They can also leverage the platform capability to create transparency in the actions that they've taken and encourage a cross-learning between the team, such as running an AWS command line through the AWS chatbot to execute AWS Systems Manager runbook and stop all these instances like what you're seeing in the screen right now. Now, what you've seen here is basically just an example of a voluntary behavior to optimize your costs, which is exactly the type of behavior that you might want to recognize and encourage others in your team to do. And this recognition can come in multiple forms. You can do things like a simple thank you, or perhaps a fiery praises along with a coffee voucher to keep the energy level up. The sky is really the limit. So that brings us to the end of our presentation. I hope this information today has been helpful. Just a couple of takeaways before we close it off. In the beginning, we talk about the pillars of AWS well-architected framework, and cost optimization being one of it. We also talk about the design principles that you could use as a goal or a direction to iterate your workload and practice towards. And to help you get there, we encourage you to consider the 4 focus areas we talk about today around cost optimization, as well as leverage the extensive tools and services around cost management, such as some of the one that we've discussed today. If you'd like to know more about cost optimization design principles, or perhaps have a hands-on experience on sample labs, you can check out the links on these pages for additional resources. And lastly, we want to thank you very much for your attention today. Thank you very much for watching. And don't forget to let us know what you think about this session by filling in the survey, and enjoy the rest of your summit.